Hi, I'm Hans Hartman, and this is Green Scene. Today we're here at the Florence Griswold Museum in Old Lyme, Connecticut to take a look at their geothermal heating and cooling unit. This old house uses the power of the earth to heat and cool and keep itself a constant humidity and temperature. Let's go inside and I'll show you what I mean. This building is very unique. It houses a lot of very fine pieces of art and very rare pieces of art that just can't be replaced. The beauty about this is that the way that they protect this art is using geothermal heating and cooling. It's not a very common practice, but this geothermal heating and cooling uses the power of the earth and the constant temperature that's maintained at about 200 feet underground to actually preserve the art treasures that are here. It not only preserves the art, but it also preserves the house itself. This was Florence Griswold's actual home. She actually lived here. And all the things in this home depict the exact time period from when she was alive and actually living here. Now I'm actually in the heart of the geothermal heating and cooling unit. There's a series of pipes and heat exchangers and filters, and all of this really all works together to take the cool that is in the earth at 200 feet down and turn it into dry, cool air during the summer and dry, cool air during the winter. It's just an exchange of heat through water, and that's fantastic. So we're here with Ted Gaffney, the facilities manager of the Florence Griswold Museum. How are you, Ted?
Fine.
Good. Now, we were looking at some of the things with your geothermal heating unit earlier. Could you just explain to everyone what geothermal heating is?
We use the ambient earth core temperature of 56 degrees. And we do that by drilling a bore down about 250 feet through the gravel that we find all through this part of the Connecticut area. And we hit the bedrock where we have the constant 56. Now we do a series of 16 bores or even 18 bores, and they're all connected together through a closed loop PVC piping system where we then will run our medium, which in this case is water, through the PVC. The water acts as a heat exchange, the medium for the heat exchange. Whatever temperature it is either going to cool off to 56 degrees or is going to warm up to 56 degrees, depending on whether you're in the summer or in the winter. That water in turn is brought back into our mechanical shed, into the basement, where the circulating pumps ensure the water is running constantly. But then it goes into a heat pump. The heat pump itself will take the water that's at 56 degrees and bring it up to the required 70 or 72, about 70 degrees. That is then used to condition the air within our handling units to get to the requisite required temperature, which is about 70 degrees. And at that point also, we also include the humidity, or we dehumidify the air that's being put into the house. In the summer, of course, you're dehumidifying. In the winter, you're humidifying. And these are also parameters that we set, by our remote HVAC controls. We run it through our system where it conditions the air. It's used as a heat conditioning. And then the water, of course, is circulated back into the ground. So it's a question of 14 degrees, winter or summer, really, because we're always just shooting for this one goal of 70 degrees, whether it's winter or 70 degrees in the summer. So is 14 degrees going to affect the temperature of the core? I don't think so.
Yeah,
I'm not an engineer, though.
The earth is pretty massive anyway.
Pretty big, yeah.
And it does dissipate the heat pretty doggone well.
And it's 18 bores, and they're all connected with the same PVC piping, so it's all closed loop. There's no, it's not like we're introducing anything of a contaminant into the ground. It's not like we're threatening the water table. It's all just within the PVC.
Great. Well, Ted, thank you very much. Appreciate it. Really enjoyed taking a look, and I'll have to come back again with my family.
Do something.
All righty, thanks.